Have you ever looked around and felt that something was off? That the world we perceive might not be the fundamental reality? This isn't just a fleeting thought from a late-night movie, it's a serious hypothesis entertained by some of the brightest minds in science and philosophy. It's called the simulation hypothesis, and it proposes that our entire universe, from the smallest particles to the vastest galaxies, is an advanced computer simulation. Today, we're diving deep into the code, exploring the scientific arguments that suggest our reality might be a sophisticated program running on a cosmic hard drive. One of the most mind-bending pieces of evidence comes from the world of quantum mechanics, specifically the famous double-slit experiment. Imagine firing tiny particles, like electrons, at a screen with two narrow slits in it. If you block one slit, the electrons behave as you'd expect, like tiny balls, creating a single band pattern on the detector behind the open slit. But when both slits are open, something strange happens. The electrons start behaving like waves, passing through both slits simultaneously and creating an interference pattern on the detector screen, a series of alternating light and dark bands. It's as if each particle knows about the other slit and adjusts its path accordingly. The truly bizarre part is what happens when we try to watch them. When scientists place a detector at the slits to observe which one the electron goes through, the wave-like behavior collapses. The electrons revert to acting like simple particles, and the interference pattern vanishes, replaced by two simple bands. It's as if the universe only renders a definite state when it's being observed. This is eerily similar to how video games work. To save processing power, a game doesn't render the entire world all at once in full detail. It only renders the parts of the world that the player is currently looking at. The unobserved environment exists only as a probability, a set of data waiting to be called upon and rendered into a concrete state. Could our reality be operating on a similar principle of computational efficiency? Is the act of observation the universe's way of rendering reality for its user, us? The implications are staggering, suggesting that the fundamental nature of reality might be information, processed only when needed. Then there's the idea of the universe's resolution. Just like the digital image on your screen is made up of tiny pixels, some physicists theorize that spacetime itself might not be smooth and continuous. Instead, it might be granular, composed of fundamental, indivisible units. This smallest possible unit of space is known as the Planck length, a staggeringly tiny distance of about 1.6 times 10 to the power of -35 meters. It's a scale so small that if an atom were the size of the known universe, the Planck length would be the size of a tree. The theory suggests that nothing smaller can exist or be measured. This concept of a minimum possible length acts like a pixel for the universe. If reality were a simulation, it would need a foundational grid, a base resolution upon which everything is built. A simulated universe couldn't have infinite detail, as that would require infinite computing power. It would have to be pixelated at some fundamental level, and the Planck length provides a compelling candidate for that cosmic pixel size. Physicists like James Gates have even found what looks like error-correcting codes embedded in the equations of supersymmetry, which describes the fundamental particles and forces of nature. These are the same kinds of codes we use in computers to detect and fix errors in data transmission. Why would the laws of physics contain self-correcting code unless they were part of a system designed to run without glitches? It's a tantalizing clue that the fabric of reality might be written in a language we are only just beginning to decipher. This pixelation and embedded code suggests that the universe has a finite resolution and built-in stability mechanisms, just as a well-designed computer program would. Finally, we come to the argument from probability, which is perhaps the most compelling of all. This idea, championed by Oxford philosopher Nick Bostrom, doesn't rely on physics but on pure logic. Bostrom's argument starts with a simple assumption: a civilization advanced enough to create a simulated universe would likely create many of them. Think about our own trajectory. We already create complex simulations for everything from climate modeling to video games. Our virtual worlds are becoming more realistic every year. Given enough time and technological advancement, it's plausible that a future civilization, or an alien one, could create ancestor simulations, highly detailed simulations of their past, like our present. If they create one such simulation, why not create thousands, or millions? Now, consider the sheer numbers. If a base reality exists and it spawns countless simulated realities, then the number of simulated conscious beings would vastly outnumber the beings in the one, original reality. So, if you pick a conscious being at random from all the realities that exist, the statistical probability is that you're one of the simulated ones, not one of the originals. It's a simple matter of odds. For every one real universe, there could be billions of simulated ones. The argument forces us to conclude that it is statistically far more likely that we are living inside a simulation than in the base reality that started it all. Unless we assume that no civilization will ever reach the point of creating such simulations, a rather pessimistic view of technological progress, we are almost certainly not at the top of the reality chain. From quantum weirdness that mirrors video game mechanics, to a pixelated universe with its own error-correcting code, to the overwhelming statistical odds, the case for the simulation hypothesis is both fascinating and unsettling. It reframes our entire existence. Are our thoughts and feelings just lines of code? Is our search for meaning and purpose simply part of the program's script? While we don't have definitive proof, these questions push the boundaries of science and philosophy, urging us to look at our world with a new sense of wonder and curiosity. The universe may be far stranger and more intelligent than we ever imagined. Thank you for joining us on this journey into the matrix of reality. If you enjoyed questioning the nature of your existence, be sure to subscribe to Space Repo for more cosmic explorations.